This is the second video reviewing periodicity group 2 and group 7, going from question 7 to question 10. If you haven't done 1 to 6, look for the video labelled part A. So question 7, the following pairs of compounds, each in aqueous solution, can be distinguished by simple test tube reactions. Give a reagent or combination of reagents that can be added to the solutions in each pair to distinguish between them in a single reaction. So I think this will be a bit clearer to you once you've done the required practical, but to go through it, the reagent, sulfuric acid or any soluble sulfate, you shouldn't see any change with the sodium chloride, but we should see a white precipitate forming with the barium chloride. Then with our reaction between NaCl and Na2CO3, again sulfuric acid or any acid really, no visible change with the sodium chloride, but we should see some bubbles going on too. You might have decided for part B to use acidified sodium nitrate. In that case, you should have got a white precipitate with the NaCl and again bubbles for the Na2CO3. Question 8. An experiment to investigate enthalpy was carried out with calcium instead of magnesium and with 2 mole per decimeter cube sulfuric acid instead of 2 moles per decimeter cube of HCl. Both acids were in excess. At first, the reaction of calcium with sulfuric acid was faster than the reaction of magnesium with hydrochloric acid. However, the reaction of calcium with sulfuric acid soon stopped even though some calcium remained. A white solid had formed. Suggest 2 reasons why the reaction was faster at first with calcium and sulfuric acid rather than magnesium and hydrochloric acid. I think a few of you will be a bit disappointed you didn't get these marks because some of these we can link to your C4 module at GCSE looking at strong and weak acids for 1 of the points. So sulfuric acid has 2 times the hydrogen plus ion with H2SO4. It's a strong acid, so it fully deionises, whereas HCl only has 1 H plus ion. The other reason, which a few more of you got, going back to your reactivity series from C4 at GCSE, calcium is more reactive than magnesium. B. Identify the white solid and write an equation for its formation in this reaction. Explain why the reaction of calcium sulfuric acid stopped even though some calcium remained. So, a lot of you got there was calcium sulfate. So with calcium plus sulfuric acid made calcium sulfate plus hydrogen. So this is our metal plus acid makes salt plus hydrogen, again from that C4 module at GCSE. And basically the calcium sulfate is really insoluble. Question 9 then. Chlorine and bromine are both oxidizing agents. Define an oxidation agent in terms of electrons. This one was surprisingly poorly answered, or maybe 50-50 in the class. So an oxidizing agent gains electrons or removes electrons from something else. So in that process gains them and it actually oxidizes itself. But you need to be referring to the electrons in this question. We're then told in aqueous solution bromine oxidizes sulfur dioxide to sulfate ions. Deduce the oxidation state of sulfur in SO2 and SO4 2-. You guys, I think 100% all got this right, +4 +6. So we were doing really well on our oxidation states. So you then had to deduce a half equation for the reduction of bromine. So the bromine is going to be gaining electrons to form the bromine ion. Similar to the iodine question we discussed in the other video, people got this one the wrong way around. Read very carefully how they have phrased the question. We're then asked to deduce a half equation for the oxidation of SO2 in aqueous solution forming SO4 2- and H+ ions. So put the equation up there. Start with your SO2 on one side, your SO4 2- on the other side, then add your electrons, then balance the charge by adding your hydrogens, then you add your water. Again, if you want to go through this step by step, look at the previous video, follow those steps. Then part 4, use these 2 half equations to construct an overall equation for the reaction between aqueous bromine and sulfur dioxide. So there we go, we've just got to combine them, nice and straightforward. The electrons cancel out, we don't need to multiply either half equation to make that work. Part C, write an equation for the reaction of chlorine with water. Below each of the chlorine containing products in your equation, write the oxidation state of chlorine in that product. So again, this is the equation that should have come up in your homework, and we have mentioned in class. So chlorine plus water forms H plus Cl minus ions plus HOCl. So in the HCl, which some of you wrote as HCl and that was fine, it's got a -1 charge, and in the chlorate it's a +1. You didn't have to tell the oxidation state of the reactant Cl2, which was 0, and lots of you identified that because they were only interested in the products. Part D, give a reason why chlorine is not formed when solid potassium chloride reacts with concentrated sulfuric acid. Chloride ions are a weak reducing agent, so they're not able to do that. Write an equation for the reaction between solid potassium chloride and concentrated sulfuric acid. Two ways you could have wrote that: KCl plus H2SO4 forming HCl and KHSO4, or you might have had it forming the K2SO4 instead. I had to just do a bit of rebalancing. Part F then. Solid potassium bromide undergoes a redox reaction with concentrated sulfuric acid. Give the oxidation product formed from potassium bromide. Give the reduction product formed from sulfuric acid. So I've got a similar equation at the bottom that kind of gives you the idea of how you should be approaching it. But basically, if an atom's oxidation number decreases in the reaction, it's being reduced. If an atom's oxidation number increases, it's been oxidized. And our products are bromine and sulfur dioxide. Question 10. I think we were relatively strong on this one and on our trends. But your first task was to basically fill in the gaps on this trend table showing the melting point. So it should have looked a bit like this. Basically 1 mark for getting the SI above 1200, chlorine, get a mark for having that below sulfur, and then 1 mark for the argon being below chlorine. So we're 3 marks in total getting those points. I will point out you are asked in the question to join the crosses. Some of you, 1 or 2 of you didn't do that. Now it wasn't in the mark scheme, so you didn't get penalised for it, but I can imagine another mark scheme where they might be a bit mean and not give you those marks if you haven't joined them up and they have asked you to. So, by referring to its structure and bonding, explain your choice of position for the melting point of silicon. Now you can see, hopefully if you got this first part right, that silicon has a really high melting point. So you need to be thinking about the energy needed to overcome those forces of attraction. In this case, they're covalent bonds. So silicon is a macromolecule or giant covalent structure. Lots of different ways you could phrase that. And there are many covalent bonds that need to be broken or overcome, and it requires lots of energy to do that. Then explain why the melting point of sulfur is higher than that of phosphorus. Now we're told the formula of sulfur is S8 versus P4. That gives us some more clues. Sulfur is going to have much larger intermolecular forces because it's a larger molecule, there's more electrons there, more atoms, and hence the stronger van der Waals compared to phosphorus. Finally, state and explain the trend in melting point of the group 2 elements between calcium and barium. So the trend is it decreases. If you don't get this bit right, you don't get error carried forward. So trend decreases, that was worth 1 mark. Because there's an increase in the size of the ion, and so there is a weaker attraction between that delocalized electrons and that positive metal ion, so we end up with weaker metallic bonding. Hope you have found that video helpful. If you're in my class, you have the mark scheme that's been given to you. Use that in the videos to go through those mistakes so you can make those improvements in time for your mocks later this year.